Moving on to the second transformation tool, we will be talking about rotating objects in perspective. Now there are different methods to rotate objects in perspective using an ellipse, using a rectangle, and using vanishing points. Some may be more accurate than the others, but some may be a bit more limited. So I will start with the most used, most unlimited method and the trickiest one of them, rotating objects using an ellipse. Rotating objects using an ellipse means drawing an ellipse with the object edge factoring as a radius to the ellipse. By rotating the radius around the limit of the ellipse, we rotate the object along with it. This way we know that no matter how much we rotate the radius, it will always be constant all around the ellipse. So let's take this box for example. If we want to draw an ellipse using the bottom edge as a radius, we need to expand the bottom face all around. Since the surrounding ellipse will be 4 times bigger, or to put it in another way, the box is 1/4 of the rotating ellipse. So let's divide the bottom edge using the horizontal line and double the distance on both sides. We connect it back to the vanishing point and get a larger rectangle with the box being 1/4 of it. We can also use the duplication method to move the box 1 unit in both directions. Now we simply draw the ellipse on the new large rectangle. This is the rotation ellipse that we're going to use to rotate the box. We will use the back edge as constant and the bottom 2 edges as the radius of this ellipse. Wherever we rotate them, they will always hit the edge of the ellipse. This way we know we are still using the right side of the box without distorting it as we rotate it. So now I can move one edge anti-clockwise and connect it to its own vanishing point. This way I can use the same vanishing point for the top edge as well. By connecting the 2 edges, we get one face of the box rotating backward. Now let's do the same for the other face. It has to move along the same direction, anti-clockwise, since the box is moving as a whole. I can guesstimate it, or to be more accurate, I use the diagonals to see where the edge which we rotate hit the 90 degrees. Once we have that point on the diagonal, we shoot it back to the ellipse, and that's where the other edge will be. Now we extend the edge back to its own vanishing point and use it to draw the top edge of the face. We connect the 2 edges to get the 2 faces of the box. With the half of the box done, we can use the new vanishing point to draw the rest of the box. And as you can see, we rotate the red box on an ellipse by keeping one corner fixed on the center and the other 2 corners of the box rotating on an ellipse. As for the last corner of the boxes, they also move on a second larger ellipse. If I draw this ellipse on the same ground but a bit larger, it will also hit both corners of the boxes. No matter where you rotate the box, it will always move on both of these ellipses. This way you would know that your rotation is correct. The rotation we did is based on a z-axis, since the constant is the vertical edge on the back of the box. Whatever edge you use as a base would indicate the axis of the rotation. You can draw an ellipse on each axis to rotate the box around that axis. Before we do the other 2 axes, let's see an example in 3D. Here we have the box rotating in a z-axis. The vertical edge in the middle is stationary, while 2 corners of the box are rotating on the small ellipse limit and the last corner is rotating on the larger ellipse limit. No matter how much you rotate it, it will always hit these limits. Here is the same example on the y-axis, where the edge we keep stationary is in the same axis. And here we see it even clearer how the 2 corners are rotating on a small ellipse and the final corner is moving on the larger ellipse. Finally, here is the rotation on the x-axis. We can add two more ellipses on top of the box to see how it's moving on both sides under the limits of these ellipses. So let's go back and rotate the box on the y-axis. The process is the same, but now we use the y-axis of the box to rotate around it. So the first step is to find a larger rectangle around the box, duplicate the base of the box toward the x and z axis. Once we have the larger rectangle, we can draw the ellipse inside of it. This time I will draw the second rectangle as well for the right side of the box, or the top side if you consider the left side as the base of the box. So we use the initial larger rectangle to draw the second one and then draw the ellipse inside of it. This way we have two ellipses to draw the box in between. It will make it even more accurate this way. Now we decide how much we want to rotate the box. So this time I will rotate it clockwise. Now I choose the placement of the first edge and freehand the location of the second edge by making sure it's 90 degrees between the two edges. Next I extend these edges toward the vanishing point and close them up at the bottom ellipse. These edges will have to fall on the ellipse edge no matter how much you rotate it. Now instead of choosing a new vanishing point according to the rotated edge, I'm just gonna assume that the vanishing point is way high up. So I will just copy the edges we already have as parallel lines to get the two other edges for the top face. I can do the same for the bottom face and we will have the full box in between. Finally, I add the outline for both boxes to show how it's rotating around the y-axis while moving around the two ellipses on top and bottom. Let's do one more for the x-axis now. Once we choose the corner we want to pivot around, we can start drawing the larger rectangle around it like we did before. Once we have the rectangle, we draw the bottom ellipse that we rotate around. Let's do the same for the top and draw another ellipse to make sure our rotated box is constrained in between the two ellipses. Okay, now we are ready to choose where to rotate to. Let's rotate it clockwise again and make sure it's 90 degrees in between the two edges. We can also use diagonals to make sure the degree is correct. Now we can connect these new edges back to the vanishing point to get the two first faces of the box. These new edges will stop at the top ellipse edge. I can now copy these edges to the other side and get the final face in the top. I do the same for the bottom to get the final box. Finally adding the outline for both boxes to see how it's rotating in the x-axis. The more you do this, the easier it will be. It will become second hand once you do it a lot. Let's try this in another way. If we are not sure how much we want to rotate the box and we want a fast way to rotate different rotations, we can draw the larger rectangle first and draw two ellipses in between before even drawing the box. Once we have the two ellipses, we can start with one face of the box rotating around the ellipse, with the center of it being stationary in the middle. Then we can start picking any location on the ellipse and draw a vertical line and connect it back to the center of the ellipse. These will represent the first face of any box we want to draw in this area. So as you can see, I'm drawing different options with the first face of the box rotating around the ellipse. Now I can turn any of these faces into a full box. Since the angle between these faces is 45 degrees, I can draw a box in between the faces by picking one face and then skipping one and taking the one after. This way I know for sure every other face will be a 90-degree angle, with the initial face of course. And just like that we get our first box. We can do the same for the other two faces. And then another one. You can divide it into an infinite number of faces as long as you make sure that there is 90 degrees in between the edges. Now we will later do other shapes than a box, but this is just a quick way to draw as many boxes using the initial ellipses instead of starting with one box and then drawing the ellipses afterward. And you can see here how they look without the construction lines. Okay, let's now move on to the second method to rotate objects. This method builds up on the previous method, but it has its limitation. It uses more of the equal intervals to rotate the box around the ellipse, like hours on a clock. So let's see it first in the front view. First I draw the rectangle and then divide it with diagonals and cross sections. Next I divide it to smaller and smaller rectangles. Let's now draw the ellipse inside of the rectangle, and all these divisions can now act like points on the ellipse to rotate the box around using these points. I can divide the rectangle even more to get the points in between. Now I have 16 different divisions on the ellipse. If I connect between 4 points around the cross-hatched portion of the rectangle, I can get an equal square. If I want to rotate the square clockwise, I can move each point of the square 1 point clockwise. By doing this, I rotate the square equally from all corners. I can do that again and get another angle of the same square rotating clockwise. It's like the previous method but on rails. You can be sure of the correct rotation angle here than the previous method, but it takes more steps to get the exact angle you want to rotate the box with here than the previous method. Let's now do it in perspective. Again, you can rotate in 3 axes here, the X, Y, or Z. Let's rotate it in Z now. First, I draw the base rectangle on the ground and divide it in each and every way as before. Next, I draw the ellipse. Now I add the verticals to see how the height will be for the box. Then I add another ellipse on top to make sure we are ending the box on the correct place. No need to divide the other rectangle here since all the lines will fall on the ellipse anyway. Now I can pick 4 different points around the base and connect them to the top ellipse. Finally I connect in between these lines to get the top and the bottom planes. This will be the initial rectangle we want to rotate. To start rotating it clockwise, let's divide the bottom rectangle a bit more around the edge of the ellipse to get even more defined points. We can do this step at first, but it's not a problem doing it when we need it afterward. Okay, now I can move each corner of the box 1 point clockwise and connect them to the top ellipse and in between to rotate the same initial box clockwise. Let's do one more and move the box 2 more degrees by moving the box 2 points clockwise and connect it with the ellipse above and between the edges. Let's now move it anti-clockwise and rotate the box backward. We simply pick the point before each corner anti-clockwise and connect in between them as well. And here are all the boxes rotated. So basically this is the second method. It's the same as the first one but with more defined points to rotate the object at. If you worked in a 3D software before, this is like snapping the rotation tool to rotate at a certain intervals instead of a free rotation. Let's do one more in the y-axis. First I draw the initial grid now on the y-axis instead of the z-axis and divide it like we did before. This time I'm dividing it right away from the start. Now I draw the base ellipse, then I extrude the box to get the exact height of the box. Let's draw another ellipse on the other side. Now I can start drawing the initial box and rotate it afterward. Once we connect the points to the ellipse, we connect in between them to get the side plane and then we connect in between the two planes to get the total box. Let's now rotate it anti-clockwise and move it 2 points backward and connect in between them. Let's do it now one more time with 1 point anti-clockwise. If the lines became too much to see through, just hide some layers and work with better visibility. And that's basically it. This is how we rotate the box in snapped, interval, or predetermined angle. The third method of rotating an object in perspective is by using the vanishing points. This method can be less accurate than the two before, but if you want to make it as accurate as the other ones, you can combine it with the guiding ellipse to make sure your box stays in the same dimension as you rotate it. I usually use this method for drawing multiple objects in different orientations, rather than rotating the same object. If we can look at this example here, we can see how by moving the two vanishing points around the horizontal circle all around us, we rotate the object connecting to them as well. As long as the distance between the two vanishing points stays the same, the box dimension will stay the same as well. So if we draw a box in 2-point perspective and wanted to start rotating it, we can start moving the vanishing point around the object. We just have to make sure that we move both vanishing points at the same distance. Otherwise, the shape dimension will start to change. Also, we need to make sure that we choose the edge to rotate at, either in the X, Y, or Z axis. Once we do that, we can draw the edge and connect it to the new vanishing point position. To know how wide the box will be, I will usually just freehand it and imagine the ellipse around the initial box that my new box will also rotate around it. If you want your work to be more accurate, of course, you can simply add the ellipses we talked about before, either on top or bottom side for the initial box and rotate the new box around it. But I will just use the first method for that. This one is just to speed things up and freehand bunch of boxes around the canvas. That's why I would use this method to draw different objects in different orientations like we did before with the drawers, if you remember that, instead of rotating the same object all over again. Also remember that the horizontal line is not a line. It's actually the radius around us as a viewer. So no matter where you turn, you will see the horizontal line. That's why the vanishing points can rotate all around the canvas, not just on a line. The vanishing points will start to go outside of the canvas or our view, and you will just have to guesstimate where they are in regard to your box. That's why this isn't 100% accurate, but in the main scheme of things, it will help with populating your canvas with objects that doesn't fit to just the two vanishing points in it. Okay, let's move on to more complicated shapes, like letters for example. We have the T letter here, and we want to rotate it around. We already learned so many ways to rotate this shape, so I will try to demonstrate a couple of methods here. For the first method, I'm gonna use the divisions and measurements. So the first thing we have to do is to draw the bounding box, just like we did for the moving tool. Once we have the bounding box, it's easier to rotate it than rotating the detailed object. Next, let's rotate this shape to the other side, while keeping the right edge stationary. So to do that, we need to know the length of the T letter. So let's use the horizontal line for the existing letter and connect it through the edge of the letter all the way to the vanishing point. Here you can see the whole length as a horizontal line with a segmentation of the inner details. To mirror this to the other side, we can simply copy the horizontal line divisions to the other side at the same corner of the letter, then connect it to the opposite vanishing point. So now we have the length of the letter and the width as well from the original letter. Let's extend these segments vertically to the top of the bounding box. We can connect the bottom of the T bridge from the existing letter to the opposite vanishing point and connect it to the edge. As for the depth, it's the same as 1 unit of the T length, so I can simply just connect it from the existing letter to the vanishing point to get the back side of the letter. Finally, I draw the whole thing with a thicker line weight and finish it up. This is an easy example. Later on we will do more harder ones like with different depths and dimensions. But this is a quick way to rotate a bit more complex shape than a box. We can also use the grid-like shape we had done accidentally in this example to draw the ellipse and rotate the letter based on its depth unit following the same steps as before. We can also get the same result by moving the vanishing points around to get the shape on the opposite side, because this rotation is basically reversing the vanishing points on both sides. And we can also use the mirroring effect, but we will talk about this one in later lesson. Okay, let's try to do something more difficult now. Let's rotate this letter in the x-axis instead of the z-axis. Basically tipping this shape on the ground by keeping the front bottom edge static and moving the letter on that axis. This time I'm gonna use the measuring point that we did in the perfect cube example. To get these points, we need to draw the stationary point. To find it, we can draw a larger circle between the two vanishing points. The stationary point can be anywhere on that edge in between the 2 points. Let's choose the one in the center to make things easier. We connect the 2 ground lines between the stationary points to the vanishing point with a 90 degrees in between. Now to get the measuring points, we copy the ground line length all the way to the horizon line. Wherever this line ends is the measuring point from one side, and the same will be from the other side. Since we picked up the stationary point in the center, both distances will be equal. Okay, so why we did all this work? We did this to measure the vertical height of the letter and rotate it on the ground. So to do that, we draw the height of the box, rotate it horizontally, and then measure it to the perspective line on the ground. We connect between the end tips of the horizontal line and the measuring point in the left half of it all the way to the perspective line on the ground to get the height projection of the box on the ground. To get the rest of the face, we connect it to the vanishing point and end it up at the limit of the other side of the letter. This is now the projection of the box on the ground. What we need now is the depth of the box. Since the box is stepped off, the depth will now be the length of the bounding box. To do that, we connect between the depth of the box and the horizontal line via the opposite measuring point. To know which measuring point to use, think of each measuring point as an axis measuring point. Everything in the x-axis will be measured to the left measuring point, and everything in the y-axis will be measured to the right measuring point. You will know which to use since the result will always make more sense being measured from one point than the other. If we measure the depth here from the right point, it will be way too small, but from the left point it will be more fitting to the depth of the box. Now I can rotate this distance vertically and use it from the corner of the stationary edge of the box. Then I connect it to both vanishing points to get the depth from all sides. So now we got the bounding box of the letter on the ground and we are basically done. All we need to do now is to connect the segments of the letter to the new box by connecting the base of the letter to the end of the fallen box. But let's make it a bit harder and divide the box into 3 equal segments just like we did for the original box. We do that by drawing a horizontal line and connect it to the measuring point or any point on the horizon line and divide it into 3 equal parts. Then we connect it vertically and back to the vanishing point. There is still one segment left for us to find, and that's the top bridge of the letter. This one is not exactly 1 unit down, so let's get it from the original shape. To get the segmentation of the vertical letter, we draw the vertical line for the whole letter and mark the start and the end of the bridge and the bottom of the box. Then we rotate it horizontally at the corner. It's important to keep the horizontal line in the same distance of the vertical lines, otherwise your calculation will be wrong. Now we connect it back to the measuring point and we get the same top of the box we have and the correct segmentation for the bridge. Now we can draw the vertical lines from it and back to the vanishing point to get the whole bridge. All I have to do now is draw the letter in better line weight and finish it up. And this is the letter tipped down in perspective. It will look a bit bigger because it's coming toward us, more than the original letter. So it will look bigger as it moves toward us and smaller as it moves away from us. Let's try now another way to rotate this letter by using an ellipse. The problem here, we don't have a square edge to duplicate around and get a perfect square for the ellipse. So we need to replicate the edge we will rotate around on all axes to get a perfect square for the larger ellipse. To do that, we're gonna need the measuring points. Now we can project the static edge into the horizontal line on both sides, then project it to the x and y axis of the perspective. Then we measure the edge on the horizontal line, copy it to the other side, and project it on both axes. We use the right measuring point for the y axis and the left one for the x axis. We end up with 4 equal lines that we can use to form an equal square. All you have to do now is connect the points to the vanishing point to create a square. Now we can draw an ellipse in the square and rotate the bounding box around it while keeping the dimensions constant. To get the depth, we either use 1 unit of the box as a measurement, or just use the same horizontal line to project the depth into a new position. From there, we can complete the rest of the bounding box. Once we have the bounding box, we can segment the horizontal line into 3 equal parts and project it back into the box to get 3 equal divisions. From there, we add the vertical lines to segment the whole face of the bounding box. Finally, we can take the bridge of the letter measurements from the existing letter. All is left now is to draw the shape in a clearer lines all around. And it's done. The letter is now rotated using a mix of 3 different methods at the same time. There are so many ways you can rotate it with, and it's up to you to choose the one that fits your work style the most. Finally, let's go back to the milk carton exercise that we did for the moving tool and try to rotate it as well. First thing to do is to simplify the object enough to make it easier to rotate. So let's draw the bounding box first. The top of the box will be aligned with the top edge of the flap all around. Once we have the bounding box, let's rotate the object by using the measurements and divisions. So let's copy the base to the front and then toward the y-axis. The shape isn't just moving but also rotating. But since the bounding box base is a square, it won't show in the bounding box, but later in the details. Once we get the base in its new location, we can extend it upward and get the upper limit of the existing box. Now for the details. For the base of the pyramid, we can copy it through the extension of the lines toward the vanishing point to the new location. As for the top flap, we can extend it toward the edge of the box and then toward the opposite vanishing point, toward the new location. Once we have the guidelines in place, we have to notice that the shape is rotated, so the opening of the pyramid will be on the other side. We can draw it by finding the center of the rectangle and connecting the corners toward it, and all the way to the back. For the top flap, we can extend the top of the pyramid upward and connect it to the back as well. All is left now is finding the center of the side of the pyramid and draw the opening cap for the milk carton. Very straightforward so far. We can also use the bottom square as a template for the ellipse and rotate the box using the ellipse like we did before, and then add the details later on the same way we did earlier. But now let's tip the carton forward, like we did with the letter. We will use the bounding box from the previous example and tip the vertical line on the table using the measuring points. So first I draw the vertical height and turn it horizontally and then project it using the measuring point toward the x-axis. From there we can extend it toward the vanishing point and connect it with the other side of the box. Now we have the projection of the carton on the table and even a bit outside of it. Next, we have to find the height by projecting the side of the box toward the horizontal line and use that as the new height. Notice that we can get the same results by projecting the depth toward the vertical line of the box itself. Once we get the height of the new box position, we can extend its perspective lines and connect it toward the vanishing point to get the final box position. Now to get the segmentation of the inner details, we can draw the vertical line again and mark all the important segments of the milk carton, and then we can project it into the length of the new box, and from there we get the same details projected on the new location. We could also do this from the start, but I'm trying to simplify the steps for you so you can later move faster on your own pace. Now to draw the pyramid, we find the center of the rectangle where the pyramid is and draw the tip of the pyramid and connect it to the corners. From there we can extend the tip to draw the top flap of the carton. Finally, let's draw the final carton using better and clearer line weight. And here is the final carton tipped face down with some milk coming out of it. Okay, let's do the same but for the carton tipped to the left side. The steps are the same. Find the projection of the height on the table, but this time toward the y-axis, and use the opposite measuring point on the right. Then we find the height of the box in the same way. Then we find the details using the same method. Then we draw the details after. Finally added the final line weight for the final drawing. And these are the boxes rotated in each and every way. And you can see all of the process shown here in a 3D representation. Rotating object is an essential tool as moving objects around. It's one of the basic skills you need to learn to not only to draw things correctly, but to manipulate them as well around your canvas. Do as many exercises as possible till you are comfortable enough with all the different methods to rotate objects in perspective. So later on we can do the same by just eyeballing the whole thing without all these detailed calculations. We have to go through this first, so later when we do it by eyesight, we don't go through it blindly, but with the knowledge from all these exercises. So try to rotate as much objects as you can in perspective using all the previous methods. In the next lesson, we will move on to the next transformation tool, and as important as the previous two, scaling objects in perspective. So we'll do that next. And as always, if you like this lesson, please feel free to leave a like. If you have any questions, leave them in the comments section and I will do my best to answer them as soon as possible. To stay notified for future lessons, don't forget to subscribe and hit that notification bell. Thank you all for watching, and I will see you in the next lesson.